everybody. Thank you for joining us for our presentation today by Group 3. Me and my team are going to be presenting on the automatic irrigation system using an Arduino Uno board. So first off, let's start with Aisha Anissa for her to explain the introduction, the scopes, and the objective. Screen.
Okay. So for this project, our team will be using a soil hygrometer sensor to measure the moisture percentage in the soil. We will use the sensor to develop and construct a smart automatic irrigation system with the help of a Arduino Uno R3 board. So our project objective is to develop a fully functioning automatic irrigation system using Arduino Uno and to develop a program code using Arduino Uno to run the irrigation system smoothly. So our project scope is the system will automatically stop supplying water when the soil reaches 18% moisture level.
All right, thank you, Aisha Anissa. So next, the components that we'll be using for this project are, of course, the soil hygrometer sensor. So this module will use two probes to pass current through the soil, and then it reads the resistance to get the moisture reading. Next, we have a 5 relay module. This one will control the irrigation system to make sure that unnecessary irrigation will prevent unnecessary irrigation to the plant. So you won't overwater, and it won't make the plant dry out also. Next, we have the R3 module. So this module is going to be like the main brain for our project. So it has all the coding and all the systems for the system to function. Next, we will be using a small mini water pump to supply water to the plants and pump water as well when the system is activated. We have a LCD screen as well as a feature to display the moisture percentage levels to make sure we get accurate reading. Lastly, it's going to be powered by a 9-volt battery, and this battery will power the whole system, including the board, which requires 5 volts, and then the other system, like the pump, with 6 volts. And next, we have the breadboard view of our circuit. So this is our breadboard view of our circuit. We can see we have the 5 relay and the pump right there, along with the LCD screen. We also be using the help of a breadboard, but you can take out the breadboard. But for this one, we're going to make it simpler. We're going to be using a breadboard. This is the schematic view. It's very quite complicated. It's very quite long actually. But if you understand, the sensor and the LCD screen will be on the right side. So the board will be in the middle, and then the moisture sensors will all be at the left, so where the plants are at the bottom. And this is the results for our components using AutoCAD. Thanks to the help of my teammates for drawing this. So we have the sensor right here. We have the water pump as well, and the 5-volt relay to use in this project. Also in KitKat, this is the model of our PCB that we're going to be using. So it's a very simple soil moisture sensor. Not that far off for the FC1. It's just a bit rectangular more and a bit wider. This is the probe that we're going to insert into the soil to get the reading. All right, now, Zul, can you please read first the discussion?
All right, for our discussion, it was quite hard at first because we didn't really understand how the module function and how it works. As the saying goes, teamwork makes dream work. So we as a team got together and discussed how we are going to plan it and develop it, which ultimately let us in develop a smart irrigation system. All right, in conclusion, our team has gained the knowledge to develop a fully functioning automatic smart irrigation system using Arduino. We have learned how to build the circuit, construct the component and PCB using programs such as Fritzing, KitKat, and AutoCAD. Other than that, we have also gained better team working skills by doing research about our project and figuring out and solving the problems related to the project. In summary, we learned new programming skills using Arduino Uno, and we have also gained knowledge regarding how to design our own components and PCB using certain software. Plus, we have learned how to work as a team better than before.
Okay, thank you. Thank you, Zul. Next, we have the recommendations. So, Ahmad Faizuddin, could you please read first the recommendations?
A recommendation for this project, instead of using a restrictive probe module, it is better to use a capacitive probe module because it will last longer and won't corrode over time, thus increasing the lifespan of the system. We can also add a larger pump and water pipe so that the water given can be used for more than one plant and the watering will be much more effective and worthwhile. Using capacitive probe module can give better results and reading on the moisture level or percentage.
All right, thank you Faizlin for your explanation. And now these are the references for our project. So big thank you for Circuit Digest and Datasheet Hub for the information that we have taken from the websites and for the inspiration. All right, so that concludes our video presentation. Thank you everybody for listening and good day. Bye bye.
Thank you. Bye bye.